advanced technologies. So now I am going to read out a brief profile of the Professor Manjuprkash Rao. Professor Manjuprkash Rao, born to Srimati Vijay Lakshmamma and Sri Sita Rama Rao in Bengaluru and studied in schools in Malleshwaram and Rajajinagar. His native place is Ramanagaram. He has completed his BE in electronics from UECE Bangalore. Then he has done his MTech from IISc Bangalore in the division of Electronic System Engineering. Then he has done his MTech from NUS Singapore. He has worked more than 30 years and he has worked in the companies such as L&T, Mysore, C-Dot, Mittal Semiconductor, Texas Instruments, Tyco International, and most recently in Honeywell Technologies Solutions as a director. He is currently heading the Industry Institute Interaction Cell and he is a professor of practice in RNSIT in the A&ML department. Now I request our Professor Suma Swami to welcome him with a bouquet. Now I request Professor Manjuprkash sir to take the dais. Thank you.
Thank you for the kind introductions. Test. Agutala? Sure. Good afternoon to one and all. With humble pranams to Dr. Hitchen, who is one of the founder personalities of this institute. I would like to start my presentation on emerging technologies. So Dr. Venkatesha, who was our director in RNSIT, requested me to address, I believe, most of second semester students, I believe. So it is I really thank for this opportunity and also welcome the faculty. Also, I see that some of you are, here. So let me. I won't bore you with too much of mathematics, equations and things like that, and this will be because you're all the second semester students. I want to keep this really focused on what is the technology trends, where is the world heading, and how we should be equipped to really take on these challenges. So let me start with let me put something like this. So I want this to be as interactive as possible. Anyone can tell what is, this is a prelude to something. So it's a preamble. If anyone can tell what is happening here. In the current context, just think about what is happening in Iran war and things. In that context, somebody can tell, what is the inner meaning of this. Good. That is, you're coming close.
That way may be acting as an anti-missile system.
Super. So, I think we all know, right? We would have heard in mythology, Puranas, right? Earlier, a demon, if he comes and leaves an astra, rishis can just put, mantra and then put the darbe, right? And then that was equally effective, right? So what does it mean from an engineering perspective? How much does a darbe cost? Nothing, right? Whereas, I know, of course, obviously the whatever arrow or whatever he throws, the demon throws, will be much more heavier compared to this. So where we are heading, as Sir said, today, if you come to the, really Iran war, right? What is happening in Iran war is a very interesting thing. Just listen to
The war
it.
between Iran on one side and the US and Israel on the other is a perfect example of asymmetric warfare. So asymmetric warfare is the kind of warfare that a weaker country levies against a stronger country. The US and Israel have very modern weapon systems, very modern equipment, and there's a lot more in terms of the type of inventory that both the US and Israel have. What the Iranians do, because they can't match
Video
our
play
spending or the sophistication of our weapon systems, is they use what they have, $30,000 drones on the
Video is not playing. I'll just pause here. Video play ಆಗಬೇಕು. ಅಲ್ಲ ಇದು ಪಿ ಪಿ ಟಿಲಿ ಎಂಬೆಡ್ ಆಗಿದೆ ಲಿಂಕ್.
Scribe makes
ಅಲ್ಲಲ್ಲ ಆಗ್ತಿಲ್ಲ. ಯಾಕೆ ವಿಂಡೋನ ಚೇಂಜ್ ಮಾಡಿಬಿಡ್ಲಾ ಅದು. Anyway, as I think as he is looking into it, so you got an idea of what is asymmetric warfare today is, right? Meaning, on one hand, what Iran is trying to do today is they are sending what is called as suicidal drones or kamikaze drones. This word comes from Japanese, which may cost in thousands of dollars. Now, USA, Israel, all these have very sophisticated defense systems, which which is like they have Patriot, Iron Dome, and things like that. So each missile costs $1 million or more. So this is an example of asymmetric warfare. Now, from an engineering perspective, why would you spend $1 million to counter something which is in thousands, $2,000 or $3,000, right? This is now an engineering problem, right? It is not just a warfare problem. It is, so engineering is also important for warfare. Defense budget is always very high. They can always pump in a lot of money, but ultimately, when it comes to economics, we need to have a viable economics. So a smaller country like Iran is able to, see the tactics what they are using is, they are going to swarm with so many drones, right? All the defenses will be exhausted, and then they get an opportunity to really, take an upper hand. Okay, so that is anyway. This is one of the challenges posed today, right? So, what do we do about it? ಯಾಕೊಂದು ಸ್ವಲ್ಪ ಬ್ಲರ್ ಆಗಿದೆಯಪ್ಪ. So, what do we do about it? So, keeping quiet is not a response, right? How we should be able to tackle some small, ಇಲ್ಲಿದೆಯಾ? ನೀವು ಇಲ್ಲೇ ಇರಿ. ಓಕೆ, ಸೊ ಈಗ ನಾವು ಇದಕ್ಕೆ ಹೋದರೆ ಎಲ್ಲ ಇಲ್ಲಿ ಹೌದಾ ಪ್ರಾಬ್ಲಮ್ ಇದೆಯಾ? ಓಕೆ, ಸೊ ಲೆಟ್ ಅಸ್ ಡೂ ಒನ್ ಥಿಂಗ್. ನಾವು ಲೆಟ್ ಅಸ್ ಸಿ ಹೌ other countries have
interceptor drones are emerging as a critical component of Ukraine's defense against Russian aerial attacks and are now attracting international attention for use in the Gulf. Developed by the private firm Wild Hornets, the Sting quadrocopter combines high speed and maneuverability with a low cost, making it a practical alternative to expensive air defense systems like the US Patriot missiles.
Right.
Capable of reaching speeds.
Let me pause it. So now you understood how a country like Ukraine has come up with an alternative, right? Which can be used multiple times against, a suicidal drone like. So when, how did Ukraine accomplish this? I mean, they did not, do this overnight. They really, innovated, and rose up to the situation that how to defend their country at a practical cost. So just taking this forward, right? Most of the best innovations have happened during the very challenging times, like during the war times. You have to keep that in mind. Always, that is something, let us, if I just say that, it won't be sufficient. Let us go, have a look at what are those, especially World War II was a game changer. So what happened in World War II? What all innovations came? Flu vaccines, okay? And then penicillin as an antibiotic, because soldiers used to get injured in all the warfare, and there should be a very effective way to treat them. It's one of the greatest in jet engines. So aircrafts were used in First World War also, very less, but Second World War, a lot of it was warfare was aircraft based. So fighter aircrafts were there. Blood plasma transfusion is also very wonderful innovation, right? Because in war situation, it is easier to make use of plasma rather than whole blood. Electronic computers came, and why were they used? Radar came, and electronic computers were used in a very unique way. I will come back to this. See, radar, atomic bomb, of course. Atomic bomb is also a very important innovation which happened. And see, computers were there, cryptography, code breaking. All these are very significant thing. So especially when it comes to code breaking, you would have, if anyone has watched this movie, A Beautiful Mind. Any of you have watched this movie? If not, good. If not, watch it. So it's a wonderful thing. What has happened is, the person who is here, right, Dr. John Nash, he is a cryptography specialist who helped in breaking German codes, which really swayed the war towards the British, as compared to like Germans. They was able to break codes, and he was really he did phenomenal things. So times of war always gives an opportunity window where a lot of innovations happen. And if you see even today, after Operation Sindoor, so much of innovation has been fueled even in India, because the way India defended in Operation Sindoor. So that is just a preamble. Now always what I do is, every start of every year, right, Times gives you top innovations of the previous year. I keep watching it. So what happened? Like, what is the summary? What happened last year? What are the top innovations? So I will anyway give all these links. I can't go through each and every product, but they recommend a few products which are outstanding. So many of you might have heard of Tesla's Optimus robot, which is a humanoid, right? Unitree is a Chinese company. So Unitree R1 is the name of the robot, humanoid. See, this is much advanced when it comes to the number of actions you can do, right? It can do somersault. You see what it is doing already, amazing the kind of engineering what Chinese have done for the Unitree. And see, just imagine, right? Today we are all we want to buy a car, right, as a mode of transport. But if I am able to get a humanoid robot at my home for the cost of a car, let's say Maruti car or something in the range of 5 lakhs, and if robots does all the household chores, then it's you get a lot of free time, right? So the technology is getting there. Okay, I will send you the link. You can have a look. Another fantastic 2025. Who you have heard of ChatGPT? Most of you would have heard, right? There is and then look at Claude. You would have heard of Claude. Claude is one other fantastic innovation what has happened. Today it has become a de facto when it comes to AI. So you would have heard in Iran war also, anthropic cloud was used to target certain sites. So sensitive sites in Iran. So this is Sonnet is one of the it is a brand name, and it is used widely for almost auditing, finance, legal, coding. So amazing innovation. This is another thing what has happened. Now, if so, I'm sure that there may be a few people in civil also here. So, what is in for civil? So, if I really go back a couple of years back, so see the quality, we keep seeing, right, the quality of construction is not good. Buildings, we have seen bridges falling in India. You have heard about, right? Many bridges falling. So, is there a effective way to know whether the concrete strength or if there is a structural problem or a material problem? So, some of the companies, what they have done is they have done an integrated sensor and also a transmitter which will be able to send a signal, right, to the transmit the status of the strength sensing to a mobile app or to a wireless network. So this is also, and this particular company, it started with Purdue, but eventually it was transformed to a company called WaveLogics, and they have received a grant. And embedding some sensors like this in buildings gives you a very predictive maintenance capabilities to see the strength of the building. So this is another. If I go back 1 year earlier, have you heard of DeepMind? Any of you have heard of DeepMind? DeepMind is one of the subsidiary companies of Google in UK, and what they have done is just amazing. Okay, so let us what they have solved. This particular product called AlphaFold, right? This is one of the AI models what they have. We know that proteins are all life forms contain proteins, and amino acids are the I would say are the building blocks of proteins. And then roughly 20 years, I'm not an expert, but the nature of the protein, right? It's combination of different amino acids in the sequence determines the protein composition. And protein composition, for the protein to be effective, a particular sequence mapped to a particular 3D structure, right? If at all, for instance, I have put it here, proteins, they have to get into a 3D structure. Why is it important is that particular structure only gives it the form and function for a specific cause in the body. So, for instance, if the incorrect folding may lead to Alzheimer's and things like that. And why is this important? Now, from an antibody perspective, this is very important, because what are antibodies? If there is a disease, what is happening? We have to find an antidote for it, and we have to have antibodies created through whatever means, right? IV or something. So they should have a particular type of structural composition, structural strength, so that goes and binds to that disease cells. Okay, so predicting this, from given a sequence, predicting its 3D structure is very important. So there was an open challenge, and then of course there is some blur here because of the projector, but in the you can, if you keenly see here, see there was a AI solution which was given by DeepMind, which can almost with 90% accuracy predict the structure of the protein, right? Given a sequence, how its structure is. So this required traditionally a lot of experimentation to determine the structure, but if you really see, the number of permutation combinations are numerous. We can't do it by experimentation. So only the experimental results are very small set of experimental results for there, but there was some open challenge set where I can go and compare what the what the model predicted and how the real structure is there. So this is one of the amazing example of how AI has solved us. Now we'll come back to Industry 1.0 and 5.0. So this is just to set a context going forward. So what is Industry 1.0? In 1784, mechanical, steam is a starting point. The moment a steam engine, that itself started to have some locomotives and things like that. Then came electric energy, right? 1870s. That the moment power came, then all our weavers, they went into power looms, from manual looms to power looms, and mass production started. Now in 1960s onwards, early electronics came into picture. So where some early computers, early electronics, and actual assembly line where things could go from start to end in an assembly line, and we could automate things came in Industry 3.0. In Industry 4.0, you all would have heard of Internet of Things, robotics, AI, and big data, cloud computing. All this came in 2000. And now what is happening is how humans and robots can co-work. And how many of you have heard of metaverse? Omniverse, metaverse, anyone you have heard? So good. So what it means is now virtual world. So what it is creating is, it is creating something like an avatar, and then you can start to virtually control a power plant sitting at home, right? So all these capabilities started to happen with metaverse. So and then of course AI, quantum computers, these are all somewhere in this all these technologies started to be available. So now the current trend is this, right? Quantum, AI, metaverse. Now one more important thing is India is we are lagging in materials as compared to Chinese. So you see the number of they are flooding our market with a lot of products. It could be electronics, it could be anything. So material discovery is also a very important aspect. And why is it? Because the future today, if you look at the future, computer chips, it could be solar panels, batteries, all these elements, right, which are used in our products, they rely on inorganic materials. So how can I need not rely on my own, what materials which already exist, but can I discover new materials which are stable? Stable meaning an AI can predict that, okay, this combination of material is a stable material. Stable material meaning it doesn't, it doesn't melt, it doesn't, it is stable at a particular temperature and things like that. So some of the AI today is able to predict quite a lot of new materials. And if you really see, almost instead of we trying out every combination of a material and finding out whether it is stable or unstable, AI can do the job for you and give a top 200, 300, 500 list, and out of which you can do a smaller experimentation. So you all know now rare earths, right? Where are rare earths used? Anyone? You know what is rare earth? Where are rare earths used? Huh? Louder? Magnets are the main today. And magnets are used in motors, right? EV. Why India is looking at a rare earth policy today, right? So much money is being given to find out where the rare earths are. So finding out an alternative for rare earths is also extremely important, right? So now China is holding a lot of, they have gone and purchased mines, rare earth mines, contracts all over the world. Now what is the alternative? So we also have to do that, and at the same time, can we have any alternative materials which have the similar magnetic properties which are similar to rare earths? This is also which with the AI help we can definitely look at how to really identify magnetic compounds, and many times AI will guide you to say that, look, take this example, right? The work has produced about 67,000 magnetic compound, 25 materials that has not been previously recognized as capable of magnetism, right? So such things is very important today. Now, next part of this is mostly on sustainability and net zero. So first of all, this chart, why I am putting it here is, we have to understand what is the cause of global warming. Okay, we all know that we keep telling that global warming is really bad to Earth. So how does that happen? So if you look at the electromagnetic spectrum here, right, what we have here is visible light, and we have a small window, infrared is there, but you see here, wherever you see atmosphere opaque to wavelengths, this is our luck. Harmful waves like ultraviolet, X-rays, gamma rays is being blocked automatically by atmosphere, right? But if you see this infrared, right, here you see a dip here, right? Wherever you see a dip, this is transparent, it comes to the Earth. Of course, don't worry about this, I can send this chart to you offline. So let us focus on this. So in infrared there is a transparency, and when you go out, right, in the hot sun, so what is it which is causing you feel that heat? It is nothing but, it is not the visible light, it is the infrared light which is falling on you, okay, which is causing you, because that has the heating property. Now, what is exactly happening? Why global warming is happening? Okay, so if you really see, infrared light comes and hits the Earth, and heat radiates back. Heat is nothing but infrared, it radiates back. So there are some good molecules and bad molecules. Oxygen, nitrogen, all other things, they allow you to pass. It just escapes to the heat escapes. What is radiated back from the Earth escapes to back to space, right? Unfortunately, CO2 and CH4, methane and carbon dioxide, all these they are not as compared to simple N2, O2, these are complex molecules. What they do is, they absorb and re-radiate. Unfortunately, this has not been shown here. You see here, example, right? It absorbs, some part radiates to back to space, some part is pushed down back to the Earth. So this is causing global warming. So you understood what is the fundamental cause of global warming, and now what happens if we keep first of all, why is there excess CO2, right? One of the ways how to prevent global warming is, people keep telling that carbon emissions, right? You keep hearing CO2 emissions, how can I really reduce it, and things like that. So we have to be conscious about a lot of things when it comes to how we can be better, right? How we can be cautious in our actions, right, to save the planet from CO2, right? So that we don't we don't really emit a lot of CO2 back to the atmosphere. Save energy at home, change your home's source of energy. Today government is putting government is putting a lot of emphasis on solar and other things. Walk, right, bike, switch to electric vehicle. Why electric vehicle is better as compared to I would say fossil fuel vehicles? Because emissions are lesser in EV, right? Because supply comes to the grid, right, and you use the electricity to charge the vehicle, and that is much safer. And don't travel unnecessarily. So we are all going for vacations, right? So that is also, and also airplanes, especially air travel is very, very harmful. And as much as possible, repair and recycle. And make, eat more vegetables. What it means is, see, today, livestock, right? Livestock or animals are exceeding, when it comes to population, they are exceeding the humans. And they emit gases, methane, and especially we have not seen that kind of livestock, but if you see various other countries which are heavily meat eating, so they are, it's unimaginable, the kind of meat consumption. So if we go to the, if we make a plant-based diet, what do plants do? They take in carbon dioxide, right? They take in carbon dioxide and they give you back food. So in a way, they are acting as a balance in the nature. So more, vegetarian food is also a plus. So let us park it here, clean up your environment. Okay, that's fine. All right. Hey, what happened? Okay. So another, so we are all ChatGPT users, right? You like it or not, ChatGPT has become a part of life. For everything we go to. So, but we are not understanding what is the, what is the negative side of it. So, where does the response to your query in ChatGPT comes from? Some data center, right? Should be, it would be in India or US, we don't know, mostly US or, many places, wherever it is, they are power hungry. So, a single data center may hold, may host 50,000, 100,000 servers, very, very powerful, servers. And this is what studies have shown is, in places where data centers are there, even in the vicinity of the data centers, in actual 2 to 5 degrees increase in the ambient temperature will be there around surrounding areas. And many of the advanced countries, they are now protesting. If a community comes and says that, if a company comes and says that I'm going to put a data center in this locality, communities are protesting. Now we keep seeing, we are welcoming, Andhra government is saying, yeah, look, Google is going to put a data center in a very positive way. It is going to create employment for people. That is fine. But the negative side is not being thought about. So this is also very significantly important aspect. Now, but we all are relying on data, right? How do we really control it? So, in case the data center is powered by clean energy, right? Solar, whatever it is. So, then, the impact is lesser, right? So, that is on the grid, it is called grid, clean grid. You take the power from a clean grid which is generated from renewable energy sources. And also we have to make sure the grid infrastructure is efficient, meaning when you transmit power from A to B. So how many electrical students are there? You have triple E students here? No. Okay, then I will skip it. Yeah, so HVDC and other things. And improving energy efficiency of buildings. So I will ask you a question. That is, so which is a better place to run a data center? Is Visakhapatnam better or Sweden better? Yeah, please tell the answer, sir. Exactly, right? So now inherently, if I have to put my computers or a data center, ambient temperature will be, if you are in a high ambient temperature, right? You have to cool the building, you have to cool the data. So we have to make sure the building itself is energy efficient, right? So meaning I have to be careful about how I construct my building, what sort of thermal insulation I can, so that it is efficient, and it will not allow outside heat to come in. Otherwise, you have to end up more cooling inside, right? And also the efficiency of data centers. Now let us assume that a company A, NVIDIA or someone says that, yes, you all have to be familiar with tokens. CS, I mean, you are still in second semester. Today, for chat GPT, right? It is all, you keep sending queries to it, some text to it, it gives back a response, right? They're all called tokens. In the language of LLMs, large language models, they're called tokens. Now, how many tokens per second it can handle is the figure of merit, right? Now, if the more it can handle, it has to burn more, right? Now, the competition will be between two companies which will consume lesser power to process the same number of tokens, right? We have to look into it, which is a better company at the hardware and software level, which can process more number of tokens per second with a lower power. Keep that in mind. Now, you keep hearing at the institution level also SDGs, right? You might have heard anyone SDG, Sustainable Development Goals. So it will be even every institute like HN Engineering College will also have you have to show SDG. So let us come to we all have understood now emitting carbon. Let us assume if you put a nice enclosure, HN college, right? What we want? Net zero, meaning no carbon should go out. Or let us assume like that. No carbon, right? Whatever, first of all, reduce the carbon emission. And other thing is, if at all a carbon is CO2 is produced, you have to absorb it back. Let us assume. Then it becomes net zero. There is, I am not neutral, carbon neutrality. People, if you would have heard of these terms here and there, and more so going forward, these are the terms which engineering community will be looking at. So, what is happening today is, as compared to the 1800s, today the earth is already warm by 1.2 to 1.5 degrees already, and you have seen the kind of disruption to the seasons, and whenever we are not expecting flood, there is rain happening in Saudi Arabia, right? All these things. And recently, have you seen, recently we saw that almost Gulbarga or Rachur, right? Full of Alaikalla. I don't think so there was a precedence for all these things. It has really gone to that level where, so now how this can be solved is, we have to be very conscious about how to achieve net zero. This is becoming a mandate, and many countries have come together to say that they are going to, they have vowed to have a net zero and carbon neutrality, right? By 2030, if I'm not, emissions need to be reduced to 45% by 2030 and net zero by 2050. Okay, these are some things very important, more important than quantum computers, AI and things like that is this. Otherwise, Earth becomes unlivable. Okay, so in that context, so hydrogen as a fuel, right? Have you ever thought, we all know that, natural gas is a fuel, but hydrogen is one of the, I would say, very most efficient fuel is hydrogen. So it's almost like, 20th century was all powered by oil. In the current century, we are almost a quarter gone. Another 3/4 is left. Hydrogen fuel is one of the, it stands a lot of potential. And the advantages of hydrogen fuel is, see what happens when in a power plant, right? In a power plant, either it could be a natural gas or thermal plant, a fuel, right? There has to be burning of some fuel, and the power is generated, and that generates CO2. So combustion always generates CO2. But if you really see, this hydrogen is such an element. When a combustion of hydrogen happens, what is the result? Is water, right? So it is very safe in terms of our friend, I would say pollution to environment, hydrogen is very, very safe. And hydrogen has a high energy to weight ratio. So why is it? What is unique about hydrogen? You would have studied chemistry, right? What is not there in a hydrogen molecule? Huh? Neutron is not there, right? Neutron is not there. So compared to other molecules, its weight is lower, right? It is one of the, compared to energy to weight ratio, hydrogen is very, very efficient. Now, if you really see, this is how a hydrogen fuel cell looks like. Let us assume that if I do electrolysis of water, what happens? Water is splits into hydrogen and oxygen, and I take the hydrogen here, and this is called a proton exchange membrane, right? What happens is, only the protons pass through this membrane. Electrons take a circuitous route, and there is oxygen coming here, and so here is where the EMF is being generated, okay? And the byproduct is H2O. H2O doesn't harm anyone. You need that. So this is the basic construction of a hydrogen fuel cell, and there are two forms of hydrogen. I'll come back to the fuel cell examples. Two forms of hydrogen. One is called green hydrogen, and other is called blue hydrogen. Unfortunately, this part is not clear. In green hydrogen, I want to use, if I want to do electrolysis, it's nothing but it's going to consume power, right? Electrolysis meaning it is nothing but a process of splitting water into hydrogen and oxygen. So, if I use the electricity from the grid, it is of, again, there is no use. If I make use of a renewable energy sources like solar or windmill, any other sources which are renewable, then such hydrogen produced, generated from such electric sources are called green hydrogen, because it is not impacting the environment. Whereas there is other form also. In this case, blue hydrogen, you can also from natural gas. Let us take CH4. Methane is a natural gas. I can get hydrogen from CH4 to H2 molecules. I can from methane also. But here there is a byproduct CO2, right? It is not there. The byproduct, there is absolutely, it is very clean. Here when I do this, it is called it is called blue hydrogen, and CO2 becomes a byproduct, and this CO2 I can't release back to the air, right? Because we already learned what is that. So now what do we do with CO2? We'll come to that. Keep this in mind. This is also, so green hydrogen, blue hydrogen will become very important going forward. And in terms of the purity and other things, you can always control, but be aware of these two terminologies. And let us assume we have a fuel cell, right? If we have a fuel cell, what I showed you, I can't power an electric hydrogen vehicle with just one cell. What I have to do? I have to make a battery pack, right? The way it is done. If you see even our mobiles is nothing but a battery pack, what is inside. Similarly, even for our EVs, right? We have seen. So a fuel cell stack is made, and then a fuel tank which is containing hydrogen is there, and there is also a battery pack here. Why do we need this battery pack? There is already fuel cell, no? Why do we need a battery pack? Backup. Because if you see the profile, right, always, sometimes you accelerate, sometimes you drive very steadily, right? What happens? Fuel cell has certain IO characteristics. So for backup in times of peak power, you need an electric backup. Okay, this is how. So right now, if you really see, what is coming out of this is nothing but water. What comes out of this? I already know that if I do, what is the byproduct of a fuel cell is water. So there will be a collection tank, and then you can discharge water. So that is. So, and also it's not just the vehicles. People have already started hydrogen powered flights also. So it is as compared to the regular flights, these are very eco-friendly. And I touched upon what we call as carbon capture. You remember there was a CO2 defined, right? I mean, we got a byproduct CO2. See what happens. How do I do a carbon capture? So it is nothing but there are 2-3 ways. Let's assume this is a power plant, National Thermal Power Corporation, or which uses the gas, right? So any power plant will have a combustion. So the output of that is CO2. What I do is I take that CO2, store underground. I won't release it to the atmosphere. So this is called carbon capture. So I have to now bring in carbon capture technologies to every process. So including power plants. Now once the CO2 is captured, I can use it for number of purposes. Let's not go into detail. So because it is a raw material in several of the cement, concrete, all those carbon fibers, a lot of things are there which you can do. But keep this in mind. Carbon capture is a very going forward. It's a very important technology. Now we can also gradually shift gears to our how is India doing with respect to all these various technologies. So India's journey we all know, because we have one of the best ecosystem, Aadhaar, UPI, and don't forget the EVMs, right? We have one of the best digital public infrastructure and digital the number of transactions what UPI transactions made per day, per minute, per second. I don't think so in the world anyone is there. We have a very solid thing. We have very solid backing there. Now, if you really go, let us look at what is India's AI revolution. How is it? So, what are the critical priorities of India? So, we were weak in semiconductor infrastructure. So, AI, compute and infrastructure, there is a lot of focus on that. So, it will help us in to strengthen our semiconductor and advance AI. We were lagging behind China, and what has happened now is there are a lot of impetus given to sovereign models. You keep hearing of sovereign models and things like that. Meaning these are the models which is not a chat GPT. It is generated by our own data sources. Sarvam AI. Go and look at Sarvam AI. So it is a AI for Indian languages. It is also mentioned here. So for India it is very important. And AI integration with the digital public infrastructure, and AI talent and workforce development, and AI adoption, right? So when you see AI adoption, it can happen in every stream, right? I can have AI in finance, audit, industry, name it, right? Industrial purpose, hospital, healthcare. We can always. This is the vision of our government of India, how to adopt some of these latest technologies. And what government of India has done is there is ANRF, Anusandhan National Research Foundation, identified several sectors as sunrise sectors. Sunrise sectors meaning emerging sectors, right? Emerging technology trends. So deep tech, quantum computing, robotics, artificial intelligence, biotechnology, and then energy security. We spoke. See all this what we spoke, right? Climate action, what we spoke. Climate action meaning we have to take an action. By 2030, I'm going to cut 45% of the emission. By 2050, I'm going to do cut 100%. So all these are and agriculture. This is digital economy and agriculture. For more details, you can go and look at this page. It gives you a lot of information on what are the what are the applications and sectors. For instance, you go and look at sectors, it gives you quite a lot. I told about advanced materials, right? Advanced materials is there, manufacturing, agriculture. So a lot of environmental science and climate change. All these are very important initiatives. So this is one other example. Look, when it comes to innovation, right? So recently, do you see in the newspaper that one gutter cleaning robot, right, which was done by a team in Kerala, has secured a big order from government of Singapore. So they were able to anticipate the needs, right? They designed it for India, and they were so innovative that they were able to compete with so many firms. So this is what is real innovation. Okay. So just to conclude, so I would say, stay curious. So don't just how it works. Knowing just how a particular thing works is not the end, right? You should ask why this world needs that, right? Why a particular so it only shows the application nature, right? Knowing just knowledge, what knowledge our education institution gives is how things work, right? Take that how things work to how this can be sold as a product and why someone will buy this. So bring that perspective and what problem it is solving. And stay curious, stay uncomfortable. The moment you stop being curious is the moment you stop learning or innovating. Engineering is superpower. So you are the bridge between the crazy idea and a global solution. And what if you really observe, I didn't touch upon a single element here, neither electronics or electrical or computer science or something. It is all interdisciplinary problems, what we have seen so far. And I'm sure that all the first and second years now have to go through an interdisciplinary projects, right? In our institute is happening. What is it called? That is also there, and then interdisciplinary project is also there. So don't just be bogged down by IoT. I did IoT for this. There are wonderful problems to solve, right? Think along these lines, and if you win in interdisciplinary thought process, you will win the world. And the best way to predict the future is to create it. Okay. So thank you. If you have any questions, I will. Let me know if you have any questions. And I know you all came back after lunch and.
I have one question.
Yeah, please, sir, please.
Sir, you are saying that whenever we are converting hydrogen energy into the fuel, then we are getting the waste as a water. Sir, can it be used for the other purposes, not only for drinking? In fact, I am not using it for drinking, for other purposes. Is it going to be useful?
Very much, very much. It's like, see, the thing is, for all these fuel cells, right, you need pure hydrogen. And oxygen comes from the plant, from air. So combine it, it is pure water. Pretty much doable. Outcome you get is power, electricity. Byproduct is water. What you get is electricity.
So, is it theoretically possible, like if we hydrolyze the water we get, and then again use the same water in the fuel cell, so that we can
That is what they do. Exactly. See, the water which goes back, it will go through another electrolysis process and then it is fed back.
So basically we are creating an infinite power supply.
You can't call it as infinite because it is, you see, there will always be losses. Okay. See, what happens is, even if I go back to the fuel cell, right? Not every, see, you throw at the fuel cell some 1 lakh molecules. How many will, cross that PEM barrier? Maybe 50,000 will cross. What happens to the rest of the H2? You recirculate, take it back. There will be one control loop. Understood? Okay. Yes, sir.
Government is talking of hydrogen trains now.
Yes.
There are a lot of things going on and people are.
Sir, please sit down, sir. It is interactive session, sir. Please, please.
So when that is the case, how will they be able to economically give it? Okay, environmentally, yes, it may be friendly. I agree. Water reusability, fine, no problem. Because it will be a pure water and you can add some minerals and use it for drinking purpose or use it in some industry for.
Exactly. Agriculture, you tell anything, anything you can use it.
Yeah, deionized water you can
Yeah,
use
yeah,
it
true.
free of cost. But what about the economic part of it?
Sir, economics to make it work is the big challenge. So what is happening? So it can't be done overnight. See, the thing in hydrogen.
Going on for the last 3 years.
Yeah. We have a hydrogen train. We saw that hydrogen train. See, the situation here is because we are leading in hydrogen train. So what is happening is transport. See, the bottleneck in the hydrogen economy is transportation, storage. Storage is the big problem. So as much as possible, how the hydrogen economy works is, as much as possible you produce there and consume there. Otherwise, hydrogen has to be converted into another stable form like ammonia. Right? Again, it means that I have to break it down. That will be expensive. So as much, exactly. So the storage and also the compression ratios are too high for you to really, because if in case of a hydrogen tank, you really compress it to 700 bars. 700 bar is like, if something happens there, it is explosion. It is a hydrogen bomb. So these are the challenges what we have to address it. Okay. Sir, by the way, I am from AML, but my curiosity was only the thing. So when I started to look into the sustainability, oh, sure, sir. Yeah, please.
Emerging technology, silicon basically, the workers for the last 40, 50 years. What's going to be the fate of it?
Sir,
Survive or
oh, yeah, absolutely. See, today, sir, please sit down. Sir, what has happened is in silicon, okay, I have one slide there. See, there is something called Moore's law. You have heard of it, right? Now we have almost come to the plateau of it, right? Meaning every 18 months, the density has to, right? Density will double. And we started to see, today because of Moore's law, we are having more power than PCXT, PC80. You would have seen, sir, all those things, right? So now what next? So next is, now we are at 3 nanometer technology. Even execution they will come. 7 nanometer, right. Aspiration wise, I think we are 3 nanometer also will become a practice. Beyond that, it is hard to scale it vertically. We call it as shrinking. Now, that is where, how do we, 2D technology is coming. How do I stack it up? Not the horizontal, right? My real estate, how I build the real, I mean, all our builders, right? What our builders do is plants. So that is one way silicon, even I have not studied too much there, but 2D is coming up. So there is a lot of focus how I can scale it up in that. And also gallium arsenide and wafer size. Sir, but that wafer size won't. Sir, that is there. That is there. But whatever the wafer size. But bottom line is what comes to is what is your geometry. What is the geometry, right? The gate size it comes. That you can't shrink below certain level. Exactly, you can't because of the breakdown. What happens, right? So proportionally, if you see when you were doing electronics, we had 5 volts, right? Now it has almost come to all the core runs at 0.8 volts, and only the peripheral I'm going to boost it to 1.3 or something like that. Sir, are you from electronics? That is why. so now it has to grow vertical. So that is my visibility. So. Yes, sir, please. Huh. DeepSeek is also fantastic, sir. It's a very good point. What you mentioned is just that there is some bias against Chinese in these time innovations. But sir, there is a see what DeepSeek uses, sir, is a mixture of experts. It's called. It is like your sir. Are you from by any chance AI side? Computer science. Okay. So DeepSeek does very well to train and to infer models, but its architecture is called a mixture of experts. MOE. Okay. Now there are cases where it will break. Right. Claude is super solid. I mean, DeepSeek, the way they say is for certain reasoning and other things. It's very customized for certain tasks, reasoning. So Claude is a general purpose model. So even for defense grade, they have been able to make.
Thank you very much, sir. It was very informative. I assure you that our students will make use of all these technologies, and they will be able to at least build a prototype of these technologies. I'm grateful to you, sir, on behalf of our management. Thank you, sir. Thank you very much, sir.